So let us start this demo by opening a CAD model using the Hoops demo viewer. So I open a SolidWorks model. We can see nicely the geometry definition with some colors, identifying the materials on the part. This is all what we know. We are opening a CAD model, and actually what we will try to do is to define here now the next step for the CI workflow. So when opening the CAD model, we see a first tessellation that will be the key ingredient for the following demo. We will export this first CAD model into a file that we'll call the WALEC front exchange. So I am exporting it in binary with a high resolution for the tessellation, and then I have created an STL file. Thanks to Hoops Exchange for generating that. Then I will move to the world of CAE. So I will open such model in Citron Analyzer visualization, and we will display now the exported mesh. We can see that the geometry is there in only one part. We can see there is no half result, and we can see that the first tessellation has been generated. But while inspecting the model, we notice some kind of artifacts. Actually, there are some kind of not well exported tessellation that are natural when exporting a CAD model into a finite triangulation. So this is quite complicated because it's a key ingredient when starting the CAE workflow. So I will try to highlight exactly the overlay elements you can notice here right now. We have a face that is overlaying other faces that happen when there are some internal faces, or maybe when there are some junction or other parts. But what we will do, thanks, we have Polygonica. So let's use that part and let's import it into Polygonica and let's just heal it. Polygonica will do a really nice job removing all these artifacts. I am showing here now the clean XTL file from Polygonica. Even though the Polygonica proved to have exported now a valid tessellation, what we call, and the model is well enclosed, we notice a little detail that this tessellation is too large, what it means that the quality of the triangle are not so adequate or appropriate to make a final element simulation. But we can see also that the triangulation have almost 2,000 triangles, and of course we will start use that as an input. But we have another amazing product that we offer that is from Visual Kinematics, the exporting of the mesh. We will use that output of Polygonica to import it in our mesh tool, and we will generate from that corrected STL file a newly 3D tessellation specifically adequate and adapted for computing and doing simulation. We have generated now a tetrahedron from that, and we notice that the triangulation is now a much better quality. We can see because these are more like same length on the triangle. There is just one flawless, there is no result in that aspect. But let's move to the another product that we can offer, which is the solving part. And let's put some numbers into those results. By using the another amazing product from Visual Kinematics, let's make a finite element simulation and let's display the displacement and the stresses. And we are finally getting to that result here, where I will show you in the 4 meters stress in a logarithmic scale, removing the mesh to see some nice color. We see here the full complete pipeline from the CAD file into the final result. But let's wait a moment, we haven't finished. So please everyone, prepare your phone. We will share that model into the cloud, and now you can finally finish the workflow by sharing your results to some peer. And if you have a phone, please take a moment to add this QR code, and then you can see how nicely it can be interacted in your phone. I will just give another minute here, and then I have another slide we show. I would like first to thank many people that have helped me in this to show this workflow. Please notice we moved from a CAD file into a final simulation result. This is a full pipeline for the workflow for the engineers, and we are able to do it thanks to the product that we can offer. So now let's move to the next slide. So this will recall what we have been doing in the hackathon. So I will use the same model now to prove another example, which is to be interactive. In the same way, I have imported the CAD model, and now I can add force. So what I'm doing here also is that I am overlaying the original geometry. And of course, I am a little bit amplifying the deformation, but we can see interactively how this part, after fabrication and it being operating, will be deformed from its original part CAD design. So we can start thinking about generative design here for ways of coming back and validate the CAD model thanks to the quick and fast answer and structural design we can do. So I find this really nice. So this is going together with the hackathon project, and notice how we can interact. Very good. So we'll finish soon. So here I show the final part, as saying, and you can see the forces being applied and some nice results have been interactively. Finally, just to give a full overview, what we have done here, we imported using HoopTech Chain. We exported and we repaired it in Polygonica. We mesh it using our tools mesh. We solve it using also our product. And finally, we visualize, analyze, and share using our visualization and analysis tool. Thank you so much. And thank you, Artur, so much for helping me in this demo. And thank you for all the people involved, for all the help that people have given me on Slack. And that's it. That's my demo. Hope you have enjoyed.